thank you very much. So at Untitled, we are a bit crazy, and we decided to build our custom CI pipeline and system from scratch. And it is composed of three main components: OCurrent, which is how we write the pipeline, so builder, how we execute them, and OCluster, how we manage all of our machines and everything. But first, we love the OCaml programming language. We eat OCaml, we sleep OCaml. If you have never heard of it, this programming language, it's just a short introduction. It's a general purpose programming language. It's a functional programming language. It started in academia, but it's now more used in the industry. And we like it because we find it's very expressive. It's statically typed and strongly typed, so it has a nice type system. It's memory safe, and we think that by combining all of this, our programs are more secure from the ground up. And this is just a little snippet of code, and with that you will be able to balance a binary tree. So welcome aboard the OCaml train. We are heavily involved in the OCaml community, and we maintain the OCaml package manager called OPAM, and it's a package manager and a package archive. It has around 4,000 different packages and 24,000 different versions of each package, of different packages. We have a small team dedicated to maintaining this archive, and it's basically making care that each package has explicit version constraints of its dependencies. So when you submit a new package to the OCaml archive, the OPAM maintainer will run tests and check and write the correct dependencies for you, and then make it available to everyone. So the goals at REDS are really to test the OCaml ecosystem at scale, to assert the health of the ecosystem, and to empower the developers, the normal OCaml developers, but also the OPAM maintainers. And for that, we have built a collection of different CI pipelines. So the first one of the biggest one, is OPAM health check, which weekly will build all of the OPAM packages on a wide variety of systems and architectures, and print out the difference between the previous weeks. So which package suddenly has stopped building, or which one builds correctly now. OPAM repo CI is a pipeline that will run each time someone wants to publish a new package on the OPAM archive. So this one will compute the set of dependencies and the set of reverse dependencies, and will try to build the reverse dependencies of a new library. For instance, if you are breaking all of the users of your library with the new version, you will be notified, they will be notified, and the OPAM maintainers will write the correct set of the version dependencies in each of the packages involved. OPAM, so these two ones are facing the users of OPAM, and more specifically the maintainers. OPAM.CI is a CI that faces all of the users of OCaml, because it will build the documentation of each package and publish them on the official OCaml website. And we can leverage all of the explicit version dependencies to specifically build the documentation of a specific package at a specific moment in time, and also build the documentation of the dependency cone of this package, so that you will have a correct documentation. And then OCaml CI is a pipeline designed for projects, OCaml projects and users. It's currently deployed on 400 projects on GitHub, and you can see it, for instance, on one of my projects. So it will build my new PRs just before they get rejected by the senior developers at my company. And one I really like is the Docker base image. And this one is a huge pipeline that builds OCaml and OPAM Docker images. So they pre-install the compiler and all of the tooling on Docker images. And it runs on lots of Linux distributions. It runs on, it builds also Windows native images, and for 13 different OCaml versions and configuration of the compiler. So of course, a little dogfooding. We are writing these pipelines in OCaml, and for that we have a nice embedded domain-specific language, which is really just a long term for it's a library, and we use it to describe our pipelines. And this has the advantage of that we are not using YAML, we are not using embedded JavaScript, like I'm looking at GitHub Actions, for instance. And when I write YAML, I'm always toggling the tab space because I never know which is the correct indentation of YAML. And now I'm using the real programming language to write my pipelines. And as it's in OCaml, I can also leverage the entire OCaml ecosystem, so I can use any library that I have previously tested with the other pipelines. So on this address, you'll see a nice overview of all of the pipelines and the OCurrent ecosystem. So this, for instance, is the most simplest one you can think of. It's assume you have a Git repository with inside a Docker file. And this pipeline will keep track of all of the changes of the local Git repository. So if you push a new commit or change to another branch, it will fetch this, this repository, and it will become the source of the next build stage. So the Docker build will build with the Docker file, and then this image will be fed into the next build stage. So the Docker run, which will run whatever is inside this image. So this is just a little snippet of code. I find it very readable, and then we have a nice graph of this, the whole pipeline, the computation. So we can see which build stage have succeeded, which one are running, or failed, or haven't yet been executed. All of this is based on a very little small library called Current Inc., which help us build this graph of computations. So you define a value that can change over time. You define a computation between values. They can also change or produce new values. And Current will automatically keep track of changes and propagate them across the computation graph. And this has a nice property that it provides you with automatic caching of every step, of every build step inside the graph. But it is also very abstract, very primitive. So we've built a set of plugins, which is kind of a toolbox to write complex CI and CD pipelines. So among these plugins, the first one we can think of are those that will monitor events or will be at the source of the computational graph. So for instance, Git Events, as we've seen before, so a new clone of a Git repository or a change, a push, a new branch. These are just function signature in OCaml. So current Git the clone will take an address and return a reference, a commit that is wrapped inside this caching, this library that we use for computations. We also can monitor webhooks from GitHub and GitLab. So for instance, this function will return a list of all Git references that the CI will monitor and rebuild. So this is useful when you open a PR or an MR or anything, and the CI will just fetch and rebuild that branch. We can also monitor for new pushes on Docker Hub, on Docker images. And as we have UIs for all of these pipelines, we can keep track of clicks on buttons and whatever happens in the UI. And then outputs. OCurrent is capable of producing Docker images, sending notifications on Slack, on Matrix, and on build statuses on your favorite Git forge. This is an example of the function signature to post a new message on Slack, and you can see so the caching underneath. If the key to this message doesn't change, then nothing is done. But if the key changes, then the new message is posted. We can also produce build artifacts and logs and publish changes to the web UI. But this is fairly common, but what is more interesting is that by defining these pipelines in OCaml, we can statically inspect them and show the whole graph as it's currently executing. So from bottom to top, it's keeping track. This pipeline is OCaml CI run locally on itself, so it's checking itself. It's keeping track of the current Git reference, the head repository, and then keeping track of the OPAM archive, so all of the OPAM packages. Also watching changes made on a whole bunch of Docker images with Debian and OCaml and OPAM pre-install. It's analyzing then the set of dependencies of OCaml packages it requires, and then running a bunch of linters and building my code and executing the tests on these two Debian systems, and then showing me a nice summary on either the command line or the web interface. It has also the advantage of being completely reproducible. So at each step of the pipeline, we can output a Docker file that you can copy-paste and re-execute locally or anywhere. And this is also me copying and pasting the Docker file of my PR that I made. So completely reproducible. Now, how do we actually execute these jobs? So we've made a lightweight Docker build that we call OBuilder, and it takes a build script and performs the build steps in a sandboxed environment. So it's really simple. We've been leveraging software components that are widely recognized. So on Linux, it only needs a snapshotting file system, such as BetterFS or ZFS. So it will execute the current job inside a BetterFS subvolume, for instance. If the build step succeeds, it will make a snapshot and reuse it as the base of the next build step. And it's clever enough to be able to reuse all of course, these snapshots if the different jobs, different build scripts are based on the same image. On Linux, we use runc to manage our containers. And on Windows, this is what I've been doing mostly for the past month. It's porting OBuilder on Windows, and for that, we have converged on using Docker images and Docker run to emulate this snapshotting and runc and the container management. So I can use either native containers on Windows or Hyper-V and VM. And on macOS, it's slightly more difficult, and we've converged on using rsync and user-level isolation for the sandboxing. And we are also experimenting with FreeBSD and DFS and jails to port OBuilder on FreeBSD. So OBuilder jobs are described with the S expression. It's just a Docker-like syntax. So this is the exact same job that I showed you before, but with the Docker file, but expressed as an OBuilder job. So it's just a text file, or you can also use it as an OCaml library to send new jobs directly to OBuilder. So as a summary, the pipelines we write with OCurrent, they are well integrated with the webhooks and webhooks from your favorite service. They are native and efficient. For each platform we run them on, we have found a native and efficient way of building them. Efficient, sometimes not, but sandboxing. It gives you automatic caching at each step of the pipeline. They are fully reproducible and inspectable, and they are not YAML. So you have this amazing type system. You have real values, real objects from a real programming language. Okay, now we've seen how we write them, how we execute them, and at the end, the OCluster. So what really happens behind everything. So we run them on Linux, on different architectures, on AMD 64, on 32 bits, on ARM, on PPC, on RISC-V. We have also ports for Windows and for macOS. And what happens is that each worker is put in a pool, The clients, which are the pipeline, will talk with the scheduler. So they will send them either a Docker job or a no-builder job, which is decorated with sufficiently enough information so that the scheduler will know in which pool to put it. And the scheduler is smart enough to push jobs that look alike on the same physical worker so that it can reuse the cache. Each worker, when the job is executed, does the log forwarding and sends back the logs to the client. Now for the sysadmin properties, so our sysadmin has a nice tool that allows him to see which workers are currently running, if they are overloaded, what's the state of the disk quota, of the memory, the bandwidth. So everything outputs Prometheus, metrics, and Grafana, and anything you want. We can also see which version is currently executing and provide an estimated time of execution of everything that's running on them. The communication between all of these components is done using capnp, Captain Proto, so this is really good for security and also to make sure that we are not mixing traffic from different nodes that shouldn't be communicating. The deployment on each physical machine is done with Ansible, but this is just for the base system, and we actually have another pipeline that keeps track of the changes on the main OCluster repo and redeploys them whenever we want, however we want, on the different machines. Yes, I was a bit fast. So, so we have these really three independent components: OCurrent, the language, the DSL we use to express these pipelines, and that in OCaml that leverages the OCaml ecosystem. And then a builder, this lightweight Docker run that we have deployed on Linux, on Windows, and on macOS. And then OCluster, so how we receives jobs and dispatches them to the appropriate physical worker machine and sends back all the information to the client. So you can see most of our pipelines on this address. Everything, of course, is free software. It's pH2 or ISC or MIT. And all of these projects were started by Thomas Leonard at Arides and since have been supported by contributors at Arides. Thank you very much for your attention. And if you have any questions, I'd be happy to take them.